All right, so I guess that was hiding. I'm gonna do the first 20 problems on your sheet from this morning, especially for the folks who weren't there. I guess I gotta get you the email or the Zoom link. I'll do that at the end of this video, or I'll send it with the video. All right. So you pause the video. I've got the sheet in front of me here. I'm just gonna do the problems and quickly, because you can replay everything. And we'll go from there. So the first question was the sine of -7 pi/6. Sine of -7 pi/6. Can you see that? Yes. So I'll get a circle and I'll do the bottom half. Try to get those pieces to be the same size. 6. So 7 is right there. Draw the circle and the triangle. And I think it's a pretty good drawing. And so we got a 30-degree angle. So that's positive 1/2. Man, if you can do that in your head and just write the answer, feel free. You don't have to copy that down. All right, next problem. Let's see. Cosine, arcsine, -2/9. Cosine, arcsine, -2/9. Okay, the arcsine is this drawing here. So we have 0 here, -2/9 would be about here, which means I come over and I draw my triangle right there. And if I do that, I don't need the arc. It actually gets in the way because I don't want to work with fractions. I want to work with the hypotenuse always being 1. No, sorry. Tired old man here. So I have to write -2/9 in this instance to get away from the unit circle. This drawing is easier to work with. So you got 81, you got 4, you got 77. So the square root of 77 adjacent over hypotenuse. We don't need to go to Google to find the value of the angle. The value of the angle might be maybe -20 degrees, something like that. But there's your answer to problem number 2. Problem number 3 on the sheet I butchered. I didn't realize it. It was an arc cosine. So it was an arc cosine, and I had put 2 in here. But you can't put anything bigger than or less than -1. Can't put anything bigger than +1, less than -1. So what I had done in my mind was I wanted 2 radians. I wanted 2 radius lengths to come to about there, to have you think about that. So I forgot what I was doing and I put a 2 in there. What I really should have done is what I did over here is the cosine of 2, and that's equal to -0.41614, and it keeps going 68. And that's what I wanted to give you, which means that you'd have to, draw the triangle on the cosine arc. That's pretty good drawing, right? I'm doing a little better here. So that's 0, that's -1. -4.16 might be right around here. There's -0.41 distance for width. So it looks like we're going up and then back down. And then we're asking the question, or I'm asking the question, what is that angle? And you could put it in degrees. So if you type this on Google and did in degrees, you're going to get that in degrees. But generally speaking, it does radians. And I didn't push this yet. But if you do type this in, I know I lost some decimal accuracy because this keeps going. But I'm interested how close to 2 Google would get it. And we have to see. So 2 radians is this. I wonder how good I did there. Let's just get a sense. So that's 1 radius length. So that's about 1. And then, yeah, pretty good. That's about 2-ish. So all good estimates. I forget what it was in degrees, but you can check it out. All right, so that was a misprint. That has no solution, cosine 2. Okay, this is a number between 1 and -1. Therefore, it's a ratio. You might think of it as 416, -416 over 10s, hundreds, thousands. Okay, and then draw a picture accordingly. But decimals are ratios. Next one, sine x plus cosine x. Well, we're gonna do the sine of x plus the cosine of x. And we're gonna square that. All right, well, first thing you gotta know is x is an angle in this case. This side is the sine of the angle. This is the cosine of the angle if you're in a unit circle. Okay, you don't have to divide by 1. So therefore, that's the sine and cosine, which means that we do Pythagoras. Sine squared plus cosine squared is 1. Now, I don't have that written here because the squaring is outside the parentheses. But we are getting better at doing this binomial squaring. And you can shortcut. You can go sine squared plus 2 sine cosine plus cosine squared. You're in class. If you're thinking it out, you can do that. Now, we also had plus sine and cosine, sine minus cosine. I'm just using shortcut notation right now. And that becomes sine squared minus 2 sine cosine plus cosine squared. Now, I can immediately see those cancel. And I see sine squared plus cosine squared, that's 1. I see sine squared plus cosine squared, that's 1. Sure looks like this whole thing simplified to be 2. Replay it if you want. Number 5. Fifth question. That was the 5th question. Number 6. X is 8, Z is 9. So again, may not be there yet, but that's X, that's Y, that's Z. All right, so we're drawing triangles in the coordinate system. And I gave you X equals 8 and Z equals 9. So I want to know that angle. I'm calling it angle A. Capital letters for angles, little letters for side lengths. So a good drawing would be helpful. And a good estimate. Let's say that's 8. What I just drew right now is 8. I'm going to go with that being 9. Right? I can immediately look at this and go, that's 8/9 of the way there. So this is where that would be. All right, so this is 8/9 on the ruler. This is 1. So I'm guessing what that angle is. 8/9 around 0.88. I know 0.87 comes from a 30-degree angle. So I'm a little lower than 30 degrees. Well, we better go find out. And you're trying to write an equation here. If you're going to solve this, you got to be able to connect to a computer. And I said 8/9 and I put the 8 there. I'm sorry. Well, I think I was trying to write 8/9 here as in the ruler. Okay, so we're okay. So here's the picture you're working with. We know our answer is a little less than 30 degrees because this is 0.88 longer than 0.87. So to get a longer width, I got to actually bring this down a little bit. And so I got to connect to a computer. But what do I tell the computer? Oh, I got a ratio. Geez, do I know what ratio that is with respect to angle A? I know this is the opposite side. Oh, I think it's adjacent to hypotenuse. You know, I think that's the cosine of angle A. Cosine of angle A is equal to 8/9. But I just want angle A. Well, you know what? Why don't I do the inverse of angle to ratio? And let's do ratio to angle. Now let's put it in Google and let's put that in degrees. And I did that in degrees on Google, but of course I can't remember what it was. I think it was 27.46 degrees, something like that. I remember 27 degrees. I don't remember how, there's a lot more accuracy than this, but computer told me, stored information in the computer. It's got that in there. All right. Let's see what else we got. I got x squared plus 6x plus 3 equals 0. What a pain. They make you do the quadratic formula for this. Oh, there's such a much easier way. Just put it in graphing form. Oh, God. Always put things in graphing form. It's easier to do. So that's just cutting in half, like the circle problem. That's what we talked about in class. That's this, right? That's x squared plus 6x is x times x plus 6 And over here, we have an x plus 3. And we have an x plus 3. And we have a minus 9. Let's see if these things really do give us the same numerics. Let's put a 10 in here. Nah. Let's put a 5. Nah. Yeah, 5's okay. 5 plus 6 is 11, so that's 55 units if x equals 5. I'm just randomly picking some numbers. Over here, I'll do a 5. 5 plus 3 is 8 times 8 is 64. What's 64 minus 9? Oh, that's 55 units. I guess this is the same thing as that. And I'll move the 3 over here. So that's your first step. And you're trying to learn how to use this, completing the square method for putting circles in graphing form. So you want to get good at it. Rest is a piece of cake. X plus 3 squared. And you don't even have to write this out if you don't want to. I mean, we know we're going to do what? The last thing we're going to do is we're going to move positive 3 to the other side, so it's negative 3. We know we're going to put the 9 over there, so that's 6. We know we're going to undo squaring. There's no reason you just can't go right there. But hopefully you can see, bring the 9 over, bring the square over, plus minus square root, that takes care of that. And then tuck negative 3 over with that, and you're done. And not so hard. Now with some practice. Let's get some practice on it tomorrow in class. Okay, give you another one like that. I'm just going to change this up. I got a picture, z equals 6, and z equals 6 means that's your hypotenuse. Okay, we're just going to get used to each other with this notation. A is 63 degrees. Oh, I'm giving you an angle. I'm actually giving you an angle. I got a feeling you're going to give me a ratio. I think I can draw this. 63 degrees is something like that. That's 6. Or drop the perpendicular. What am I looking for? I'm looking for the y. I'm looking for the length of this dotted line. And you're pausing the video and thinking about it. You got to write an equation. You got to write an equation. And I see an angle, and I see an opposite side. I see an adjacent side. This is what I see. And I see an hypotenuse. I guess I've given you opposite or adjacent, but we're after the y, so it sure looks like this is a sine of 63 degrees equals y divided by 6. So all you have to do is do 6 times the sine of 63 and then in degrees. And it'll give you your answer. Do I remember what that answer was? No. I know the sine of 60 is 0.87. So if I multiply that by 6, I'm pretty darn close to what I've got here. Okay, but so I can get an estimate that way. But you have to go to the calculator and you'd have to type in the sine of 63 and make sure it's in degrees. That's how you do that one. You'll get a chance tomorrow to see if you've learned anything, because I'm going to ask you another question like that. I'm just going to change the numbers. Linear function, negative 2, 3, 5, 1. Negative 2, 3, 5, 1. Well, negative 2, 3, I can immediately go x plus 2 plus 3. I know this is to the first power, and I know when I put a 5 plus 2 to the first is 7. 7 plus 3 isn't 1, so I'll get rid of that. And I'll bring in what it takes to get from 3 to 1. Right? That's how you write that linear function. All right. And we got a quadratic 4, 7. Quadratic 4, 7. I can immediately write x minus 4 squared plus 7. And then I guess I'm going to drop a number in, see what kind of area change I get. So I'm going to drop a 0 into this expression. See what I get. Oh, I get 16. Well, 16 plus 7 does not bring me to the y value that I'm looking for. And the y value I'm looking for is 12. So 16 doesn't work. But I know how to get from 7 to 12. I can add 5. Or bring in a 5. All right, so that's how you do that one. Next is a square root function. And square root functions look like that for positive square roots. And I'm saying that the endpoint is negative 2, 3. We're back to negative 2, 3. Okay. And passes through 322. 322. I want a square root function, so I'm gonna write x plus 2. Can't use anything less than -2. Can't take square roots of negatives and put it on the real number Cartesian coordinate system. So that's the start. There's obviously a pattern there that we've established. And now we're gonna drop the number 3 in. And I don't know what you get, but I get the square root of 5 when I put a 3 in here. And I don't think the square root of 5 plus 3 is gonna take me to 22. In fact, I know it doesn't, so I'm gonna get rid of the square root of 5. And 3 plus what gets me to 22? 19. Yeah, that's what you're practicing. What intervals is the tangent function undefined? Well, tangent is opposite over adjacent. The tangent of an angle. The tangent of an angle is by definition opposite over adjacent. When is a fraction undefined? When its denominator equals 0. That's when a fraction is undefined. What is the tangent? Opposite. There's an opposite. There's an adjacent in the unit circle. When is this 0? When is that 0? That's 0 when my widths disappear. Boom. Right there. Straight up and down, there's no width. Hypotenuse is 1. Opposite side is 1, but adjacent side is 0. There is no width. So when is the tangent function undefined? In the unit circle, pi over 2, the top half of the circle, and the bottom half, 3 pi over 2. That's the same thing as 90 degrees. This is 270 degrees, right? Because pi over 2 is 90. I have 3 of those. So top and bottom of the circle, tangent is undefined. All right. Let's see what else we got. We got graphing form for minus 3x squared minus 24x plus 17. And that's my y-intercept, by the way. A lot of you continue to put it as the y value of the vertex, which it is not. So we can immediately get started with that. We have to find minus b over 2a is equal to positive 24 over negative 6, which is negative 4. Negative 4 is critical, so I say x plus 4. And now I'm going to use negative 4 to find a y value that goes with it. Because if I put negative 4 in here right now, I get 0. I doubt very much I'm going to get 0 when I put negative 4 in. So let's put negative 4 in, take advantage of the whiteboard here. So negative 4 squared 16 times negative 3 is negative 48. This will be positive 96 without even looking, but you go ahead and do it. This is 17. Whenever you add these, you get the opposite of this one, or you get that cut in half, whichever one you prefer. 48 and 17 is 65. And so there's the graphing form. And what would the graph look like? Cup shape down, negative 465, and 0 is over here, and the y-intercept is 17. That means negative 3 comes from 65 to 17 is down 48. And if I square the change in x is 4 units. If I square it, it's 16. And then you can see rise over run squared. That's what that really is. If I went over 4 units and squared, I should have gone up 16, but instead I went down 48. How do I convert that into that? Multiply that by negative 3. Yeah, that's that problem. I'm going through this fairly quickly. So this will be part 1. And for those of you who are really trying to do well in the class, if you look at it and think about it, you got a better chance of getting there. All right, log m squared to get m to the 3. I think I remember it, m to the 8. And I think I did minus 4. Let me look. No, that was it. That's all I got. Okay. Thought I did a different one in class. So this is equal to m to the -5, 3 minus 8. I like to think about this as I don't want squaring, so I'll get rid of it. I want -5. Okay, so if you can get to that point where you can just see it and understand it, that's great. Otherwise, you've got to do the command. That command is asking you, what do you put? I'll use the letter X. What number do I put here to convert this into m to the -5? And then algebraically, we know that m to the 2x equals m to the -5. Therefore, x is equal to -5/2. That gets the job done. Okay. Now we're looking at log base 1/2 to get x, where am I? 3x equals -4. So remember, logarithms need to be rewritten so that it reads a little more easily. There's no more information here, but reads easier if you say 5 squared equals 25. So we want this exponent to go on top of a half. And we want in the parentheses to get 3 times something. Now, negative means flip to the 4th. So this is the same as 2, 4 equals 3x. 16 equals 3x. 16 over 3 equals x. That's how you do that problem. Getting there. Center and radius of a circle. These can literally become 5-second questions. X squared minus 6x. We were just talking about how to write that. Again, this is a rectangle, x times x minus 6. We want to write it as a square plus a constant, plus or minus some kind of constant. So we even off the sides, and that's x minus 3 squared. And so we make that side shorter, this side longer. And if we multiply this out, we get a positive 9. I don't see it. So that's how we start that. Right? So that's another name for this. And we're also going to do it for some y's. And y squared plus 6y. So we're going to do y squared plus 6y. How do I do that? I shorten the longer side. I cut it in half. Y plus 3 squared. And again, I don't see the number 9, but I see the number 9 here. So I think I got to get rid of a number 9. And that's going to equal 18, I think. So there you have it. You got, oh, I erased that one. You got x minus 3 squared minus 9. Okay, so that's got to go. Can I just write it here? X minus 3 squared minus 9. There we go. So we're going to bring the 18 to that side. So that's 36. And then we got x minus 3 squared plus y plus 3 squared equals 36. And you didn't have to write that. If you saw that number, you immediately go to the center of the circle is 3, -3, and the radius is 6. Now, if I go up 6 units on the y's, this takes me to 3. If I go down 6 units on the y's, that takes me to -9. So the range of this are y values that never get bigger than 3, but they can equal 3. They never get smaller than -9, but they can equal -9. That's the range. And you can do the same thing with 6. In that direction takes me to 9. 6 takes me to -3. So the domain is -3 to 9 for the x's. All right. With practice, I see no reason why everyone in this room can't do that and do it quickly by December 13th. Okay? Remember, you don't have to learn all of this today, but you got to think about it today. You got to allow yourself to, let me just follow it. Gonna do it again tomorrow. Gonna do it again Wednesday. Gonna do it again Thursday. I have faith in you. We'll find out. So 3x squared. Okay. That's positive when numbers are bigger than 0, and it's negative when numbers are less than 0. But I don't care what numbers you put in, you're always going to get a positive. Except for the number 0. So I am going to put the number 0 right here. And I don't see a sign change. So I'm going to put a big fat dot there. Because I got a feeling I got something over here that's going to look like that or like that. And you'd have to understand why you get that by plugging in some numbers like 0.01 and seeing actually numerically what happens with all the terms. Okay, but I haven't put the whole problem there yet. I just spilled ink on the floor, but it's coming up. And it's black ink on a gray floor. Let me see. There we go. I just put a little water on that. And it came up. No, how nice. All right. Next, the term that comes next without my glasses, x minus 5. So we're going to multiply x minus 5. Well, I know when x is 6, that's positive. When x is 4, this is negative when x is 4. There's going to be a sign change here. There's going to be some of this plus to minus stuff going on. Ooh, boy. I think I'll put a dash there because I got a feeling my graph is either going to be above or below as I move past 5. Whoa. Yeah, what's next? X plus 2. I couldn't see because these glasses fall off. It's to the 5th power. Good thing I looked. Thought it was an even. And we want to know when this thing is greater than or equal to 0. Let's get rid of all of this other stuff. There we go. Let's get rid of that now. All right, so let's get rid of this. Get rid of that. There's the original problem. Let's get rid of this. And let's do a little sign work. A little plus and minus sign work. And I think I got to put a -2. And I think it's a dash because that's an odd, that's an odd, that's an even. Okay, so let's pick a number bigger than 5. Bigger than 5. Let's put 6 in. 6 gets me positive. 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 Is that product greater than or equal to 0? True. So I know this is true. No, false. Excuse me, sign change. That's going to stay false. This is going to be true. I know I'm going to get sign changes, but let's show you why between 0 and 5 gets us something that's false. We're going to get a sign change over here. That's going to become negative. That's going to stay positive. That's going to stay positive. So let's pick the number 4. 4 squared times 3. Yes, it's positive. 4 minus 5. Yes, it's negative. Okay, and maybe it would have been better if I put that over there, but I got a sign change for that one. And this one is always positive, right, when you square. Now, what I think I should have done, and I'm going to do it now so that this table looks a little different, and I'm going to suggest you do that. So I'm going to look at the biggest factor last. So 3x squared, and this one was x plus 2 to the 5th times x minus 5. Okay, greater than or equal to 0. All right, so we put a number bigger than 5, everything's positive. Now we're going to put 4 in. Doesn't change this one, doesn't change that one, but 4 minus 5, it changes to the 1st power. Yes, it changed. Therefore, the product is not greater than or equal to 0. False. A negative product is not bigger than 0. And if you put -1 in, it's not going to change a thing. Let's see why. -1 minus 5. -1 minus 5 is -6. Well, that didn't change. That's still negative. -1 plus 2. Well, that's still positive. That's positive. You know, to the 5th power. And -1 squared times 3. Well, that's always positive. Yeah, still false. I got the same exact thing. That's why you have a dot there. And then you take the time to see that that's true. So what do I have? I got negative infinity to -2. And yes, it could equal that. So that's a bracket. Union could equal 5. Yes, could equal 5. So bracket 5 to infinity. Right? That's one of our newer problems. We're going to do it every day. We're going to do it tomorrow. I'm going to do this at the board tomorrow, I think, because It's zoomed. I think I want to make sure you guys have the conversations you need to have. If all we get through is the first 20 problems, I'll be satisfied. All right, so now we got to go mx plus b. I've got 40 minutes on a Zoom here. I think I'm okay. Doesn't feel like it's been 40 minutes, but if this thing conks out on me, I'm going to be very disappointed. So mx plus b minus 3/7 x plus 4 minus 3/7 x plus 4, and then we've got plus 5. Okay, you've been doing these since the beginning, so I'm just going to put the answer here. So let's see. Make an x here, minus 12/7 plus 35/7. Your answer should have been minus 3/7 x. Take 12 away, positive 23/7. There you go. Not spending any more time with it on that. If you haven't done that yet, then you're slacking. ln of x minus 2 plus 1. You want the inverse of ln of x minus 1 minus 2 plus 1. Is that what I said? Minus 2 plus 1. Yep. So let me write that better. 2 plus 1. Okay, so this is a function. All right, and depending on what I put in, I get numbers out. Okay, so what would I do if I told you to show me how to solve this equation? Well, I would hope that you would take x minus 2 and on the other side write n minus 1. Then I would hope you would know that we're looking for exponents on top of e. Well, this is my exponent over here. That's my exponent on top of e. So why don't I put it on top of e and just rewrite it? And then minus 2 becomes what? So e to the x minus, what did I say? This is n becomes x, right? So x minus 1 and minus 2 comes to the other side. So there's my inverse. All right, so that's kind of awkward. So let me give you some more direction as to if you want to see all the steps. Then there's my original function. We change the x's and the y's, and then we solve for y. So the ln of y minus 2 equals x minus 1. Y minus 2 equals e to the x minus 1. I got room. So y is equal to e to the x minus 1 plus 2. All right, if this was me, I'd want to do the ln of 3 plus 1 because I know that answer is 2.1. So what makes the number 3 in this parentheses? A 5, and a 5 gets me 2.1. So down here, a 2.1 should get me a 5. So let's see, 2.1 minus 1 is 1.1. I've asked you to memorize e to the 1.1, which is 3. 3 plus 2 is 5. I didn't make a careless mistake. Last problem, number 20. The inverse tan of 1 and 1/19. I want you to estimate what you think it is. The inverse tan, that means what's in the parentheses. What's in the parentheses? Well, what goes in the parentheses of this notation? A ratio. What ratio did I give you? 1 and 1/19. Well, it'd be nice if it was just a compound. I can't remember my terms. Compound fraction? So really, it would have been helpful if you wrote this as 20 over 19. Now, what's the picture that goes with that? Well, the arctan is the same picture as the arcsine. I don't want to go to a ruler here actually goes from infinity to negative infinity. So that gets a little complicated. Okay, but what you are getting is answers between 90 degrees and negative 90. That's what you got to remember. It's the same range as the arcsine. That's enough to remember. Good drawing here would be helpful. 20 to 19, that's what you're looking at. That's the tangent, opposite, adjacent, right? We don't care what this is. That doesn't matter. We got to go to a calculator and you got to type this in degrees. And if you put that, at least that's what I did, and I got an answer. I got a nice answer. It'd be nice if you approximated your answer. 20 to 19. Well, what if this was 19? I hope everybody recognizes a 45 triangle. So if this is 20, That goes a little higher. That's gotta get a little wider. So I guessed 46 degrees. That's what I guessed, and I put that in the calculator and it was 46.46, and it kept going. That's good enough for us. 2 decimal place accuracy in class. I may not have you actually get your calculators out or your phones out during tests. I don't see how I can do that, right? And at this stage, pretty soon, at some point, we have to restrict bathroom trips because there's just too much temptation, too much ease to go, geez, this test, I'm not doing well. Oh, I want to get another. I don't want to put anybody in that situation. So, but I do think it's useful in class to see how it works so that this stuff means a little bit more to you. All right, let me put that hammer up a little bit. There we go. Yeah, all right. Back at you. All right, so I'm going to stop that one. That's part 1. And we'll do part 1 again tomorrow.